So till now we have covered member inner classes and static nested classes, both defined inside the outer class body. Okay, so there are two remaining kinds that are defined inside method bodies. Those are local classes and anonymous classes. So those we are going to discuss now totally. Okay, so if you see the code here, so void process final int multiplier class local helper system.out.println. So what is a local class here? Okay, so local class is a class declared inside a method body between the opening and closing braces of the method. Okay, it is completely invisible outside that method. No other method, no other class, nothing inside process can reference local helper. It exists only within the scope of process. Okay, like you see class local helper within void process method. Okay, so we have a variable here final int multiplier equal to 3. The final keyword is explicitly written here, but in modern Java it is optional. So what matters is that the variable is effectively final, its value is never changed after the initial assignment. Whether you write final or not, if the variable is effectively final, the local class can access it. Okay, so what does effectively final mean? It means you never write an assignment to that variable after it is initialized. So if you have int multiplier equal to 3, then you try multiplier equal to 5, so it would not make it effectively final, right? So and then the local class could no longer access it. It will be a compiler error. So why this restriction? Local classes can be instantiated and their instances can outlive the method invocation. Okay, for example, if you return an instance of local helper from the method or store it in a field. Okay, but the local variable multiplier is on the stack and disappears when process returns, right? To breach this gap, Java copies the value of effectively final local variables into the local class instance at the time it is created. Okay, the copy only makes sense if the value cannot change, hence the effectively final requirement. So if you see class local helper int multiply n return n into multiplier, right? So local helper is a class that is defined inside the process method. It has one method only, one method here, so that is called multiply, that takes an int and returns it multiplied by multiplier, the local variable from the enclosing method. Okay, this direct access to the enclosing method's local variable is what distinguishes local classes from static nested classes. Okay, so a static nested class cannot access instance members of the outer class. A local class goes further. It can access the enclosing method's local variables as long as they are effectively final. A local class can also access all instance members of the enclosing outer class, including private fields. Okay, all static members of the enclosing outer class and then parameters of the enclosing method, again effectively final. Like you see here, new local helper, then multiply 5 prints 15. So a local helper instance is created inline and multiply 5 is called immediately. So 5 into 3 equal to 15. The instance is used and discarded. Okay, local classes can have constructors, fields and multiple methods. Okay, they can implement interfaces and extend classes. They are full class definitions just with a very narrow scope. Okay, so when you will use local class, so when you need a helper class that is only relevant within one specific method, has multiple methods or state and would not make sense anywhere else, right? So in practice, local classes are very rare. Lambdas and anonymous classes cover most use cases more concisely. Okay, but the OCP exam tests them specifically. So if you see the code here, anonymous class implementing Runnable. Okay, Runnable r equal to new Runnable, then public void run, then system.out.println anonymous Runnable r.run. So what is an anonymous class? An anonymous class is a class that is defined and instantiated simultaneously in a single expression. Okay, with no separate class name. It is used for one-off implementations where you need a class that implements an interface or extends a class, but you will only use it once and giving it a name adds no value. Okay, new Runnable. So this is the anonymous class syntax. If we break it down, this new Runnable, so we have new here, right? So we are creating an object. Runnable, we are implementing the Runnable interface, and then we have a bracket first bracket, the constructor argument list. Okay, so empty here, it is empty here because Runnable is an interface and the anonymous class has an implement no arg constructor. Okay, then we have curly braces, the class body. Okay, so where you provide the implementation. So the entire expression of new Runnable, it creates a new class with no name, and that implements Runnable and simultaneously creates one instance of that class. Okay, the instance is assigned to R. So then we have override public void run, then again first bracket and then closing braces. Okay, so inside the class body we implement the run method, and override confirms we are fulfilling the interface contract. So we have r.run, it prints anonymous Runnable. So the method executes very normally. So if we have to compare anonymous class with lambda, right? So we have here Runnable r equal to first bracket closing and then arrow, then system.out.println anonymous Runnable, right? So this lambda is functionally identical to the anonymous class above. For functional interfaces, so the interfaces that are exactly with one abstract method, okay? So lambdas are very cleaner and more concise. Anonymous classes become necessary when the interface has multiple abstract methods. Lambdas only work for functional interfaces, okay? And you need state, fields that persist across method calls. You need to override methods from object, equals, hash code to string, and you are extending a class, not implementing an interface, okay? So we have to understand one more thing. There's a key syntax point, the semicolon, okay? So the semicolon after the closing brace, right? Here we see, what are you seeing? So we have here Runnable r equal to new Runnable, then curly braces, and there's a semicolon. The semicolon after the closing brace ends the variable assignment statement. This confuses candidates who expect a class declaration to end with just a closing brace, no semicolon, okay? The anonymous class is an expression inside a statement. Statements end with semicolons, okay? That's why there's a semicolon at the end, okay, in this anonymous class. Then we have another block of code here, anonymous class with state, okay, comparator. So comparator string by length, new comparator string, then override public int compare, then string a string b, return integer.compare a.length b.length, okay. So it is the same anonymous class pattern, okay, no name defined and instantiated in one expression totally. So this time implementing comparator string which compares to string objects, okay. Comparator string has one abstract method, compare string a and string b, which returns a negative integer if a less than b, and 0 if equal, and positive if a greater than b. So if we do integer.compare a.length comma b.length, so what will happen is that integer.compare x comma y is a static utility that returns negative if x less than y, 0 if x equals y, and positive if x greater than y. So this is the correct and clean way to compare integers in a comparator. It avoids the integer overflow risk of the return a.length and then b.length approach, okay, minus b.length approach. If a.length is very large and b.length is very negative, subtraction can overflow. Integer.compare cannot overflow, okay. So this anonymous comparator sorts strings by their length and shortest first. So if we have this code, right, list string names, new array list, then list of Alice, then Bob, Charlie, Anne, and names dot sort by length, then we have system.out.println names, right? We will have Bob, Anne, Alice, and Charlie. Bob and Anne have length of 3. Alice has length of 5 and Charlie has length of 7. So in modern Java, you would write this as a lambda, like comparator string by length a comma b, then integer.compare a.length comma b.length, or even more concisely with a method reference, a comparator string by length comparator.compare comparing int and string colon length, right? So but the anonymous class version is what the exam uses here to test whether you recognize the syntax and understand what it does, okay, that's it for this video. Thanks for your time. If you have liked it, please like and share and comment, please. And like we have stated, Our OCP exam portal is live now at javaocp.clustermicro.com. Please check it out. Thanks for your time.